So now that we know how to solve both exponentials and logarithms, we need to remember how to do inverses as well. And remember, to find an inverse, what you're going to do is you're going to take f of x, which is y, and x, and reverse them. You make the domain the range, and the range the domain. So f of x becomes x, and this x would become y, but everything else would then just drop down. And then your job is to find the inverse. Now, the interesting thing enough is this actually is the inverse. You can't graph it, you can't solve it. It's not very useful in this format. So that's where we're going to, of course, reverse the order of operations, just like we normally would. And the exponent and logarithm step is the new step for this unit. So we're looking for addition and subtraction right now. So we obviously have to add 3 to both sides. Once we do that, we're then going to be looking for a multiplication or division step. And this is where it becomes really critical to understand this parentheses on exponentials, because some students will try to divide by the 2 or maybe even combine these. That 2 is the base and cannot be eliminated without a logarithm. So our next step is to multiply by 4 to cancel out the 1/4. But just make sure when you do it over here that you actually distribute it. Okay, so just make sure you don't divide by a base. Bases you can't divide by them. Logarithms get rid of bases. And then make sure that when you do multiply or divide on the other side that you distribute that value. All right, so now we're going to we've done the first 2 steps, addition and subtraction. We did multiplication and division. We're now going to use a logarithm to get rid of the exponential base. So we're going to log base 2 here. And then when we log base 2 here, we don't distribute this. We just put all of this into a parentheses. All right, so we have log base 2 of 4x plus 12 is then equal to, remember, log base 2 and base 2 cancel, dropping down the exponent. And so now we have this grouping symbol that we have to do, and we just go from grouping symbol, we go right back down here to add or subtract, and it's just make sure when you subtract that 2 that it's outside of the parentheses. Now once I do that, I have to make sure that I put this in proper notation, that I don't accidentally combine things that don't combine, right? So that 12 and that 2, they don't combine. One is in a logarithm, one is not. And our last step is to then rewrite it using the inverse notation, because this y right here, notice there was never a y in the problem. The y is just easier to write down than f inverse the whole time. So just make sure at the end you then correctly write down the inverse notation for that problem. All right, so to remember what what an inverse does is if I were to put a 1 in here, I would get an answer, okay? And that answer that I inputted here would then be the output here. It changes the inputs, makes them the outputs, changes the outputs, and makes them the inputs, okay? So let's take a look at what happens with a logarithmic problem. Same deal. We are going to switch x and y. This will become x, and the x will become y. And once I do that, it's just the same reverse order of operations game that we just played, minus a slightly different thing to do in this step. So we're going to add 5 at the bottom of the reverse order of operations is addition and subtraction. All right, and then a lot of students, they kind of forget about negative signs. It really means -1. So you can actually multiply or divide by that -1. Technically, it's multiply, and so I like to divide, which means you would divide each of these, right? Don't forget to distribute your multiplication or division. So we get -x minus 5 is equal to, this would cancel, so ln of y plus 2. And then what we're going to do here is we're going to base this. So if this were a log base 3, we would base 3 it. If it were log, we would base 10 it. ln has a base of e, so we're going to base e it. Okay, so sometimes I write cursive e's, they look like L's. Sometimes I write regular e's. When I was a kid, we still learned cursive, so just realize that e thing is a cursive L. Okay, so we end up getting e to the -x minus 5 okay, is equal to, these will cancel, is equal to y plus 2. And then to solve for y, we're going to go to grouping symbol, back down to the bottom. So we now subtract 2 on both sides. Just make sure that you don't put that in the exponent. It would not be in the exponent. It would look like this, e to the negative x minus 5. Then minus 2 is down here. It's going to be identified later as the k value. Remember back when you did transformations and translations, this would be h and this would be k. And just don't forget that we have to rewrite this in the right notation as well. Can't really use y. There was no y. Y is a placeholder. Again, you really could, instead of using y, you could write f inverse in every step. It just gets tedious. So typically we just write y. All right, and there's that inverse. So inverse is not a difficult process. It follows the same process as solving, but you have to remember to switch x and y and then solve for the new y. And don't forget to change it to f inverse, because that's what y really represents in both of these examples.